So here's the general definition of a rational exponent. If you have a base a to a fraction m over n, then the denominator of that fraction tells you the root that you have to take, and the numerator of that fraction stays an exponent, right? So, for example, if we look at 25 to the 1/2 again, this definition says because we have a 2 denominator, we have to take a square root of 25, which was our base, and then because we have a 1 in our numerator, we have to take that to the first power. Now, it doesn't actually matter where you put this 1. You can put it inside the square root or outside the square root. Usually it's easier to evaluate if you keep the exponent outside. So again, the square root of 25 is 5. There still is a 1 exponent, but 5 to the 1 is just 5 again. So this definition takes what we thought the 1/2 power should mean and generalizes it to all possible fraction exponents. Remark 3 gives another example. Right. Remark 3 points out that the numerator of your fraction exponent stays an exponent. Okay? But the denominator of your fraction exponent actually becomes the index of a root. Right? It becomes the type of root that you have to take. So for example, if we look at 8 to the 5/3, right, the 5 portion of the fraction exponent is going to stay an exponent, and the 3 portion, which is the denominator, is going to become a root. Okay? So the 8 to the 5/3 is equal to the 3rd root of 8, all raised to the 5th power. And then if you calculate the 3rd root of 8, you know that 8 factors into 2 times 2 times 2, so the 3rd root of 8 is just 2, which means that altogether this expression simplifies to 2 to the 5th, which is 32. So 8 to the 5/3 is 32. Okay, that's how the definition of rational exponents work. Right. So the main idea in this topic is just whenever you see a fraction in an exponent, you should turn that in to a radical expression. And I would use this radical expression. I would put the exponent on the outside. Most of the time that's going to be easiest to evaluate. So let's work through the examples and see if we can get a good understanding of this concept. Alright, so we have a bunch of examples helping us get used to the definition of rational exponents. Example 1 says evaluate each expression. There's actually D parts to this example, A, B, C, D, but let's focus on A and B first. So we're going to start with 27 to the 1/3. Okay. So remember, the definition tells you if you have a base to a fraction exponent, then the denominator of the fraction tells you the type of root you should use, and the numerator of the fraction tells you the power to take that root to. So in this case, my m is 1, that's my numerator, and my denominator is 3, which is the n. So 27 to the 1/3 is equal to the 3rd root, or the cube root of 27, raised to the 1st power. You know that 27 is 3 times 3 times 3, so the cube root is going to change that group of 3 identical factors into a single factor. But copy this exponent down because we haven't dealt with that yet. However, in this case, the exponent doesn't make much difference since 3 to the 1 is still 3. So our final answer for 27 to the 1/3 is 3. We've gotten rid of all our radicals and all our exponents, so 27 to the 1/3 evaluates to 3. For part B, we have to evaluate 36 to the 3/2. Okay. We're going to use the same definition. Whenever you have a fraction exponent to evaluate, you turn it into a radical with an exponent. Okay, so 36 to the 3/2 is going to equal the square root of 36, right? The denominator tells you the type of root, and then you have to cube the result because of the numerator of the fraction. Now start inside the parentheses and actually evaluate the square root of 36. Okay, 36 is 6 times 6, so the square root of 36 is going to give you back a single 6. Then you still have this exponent to deal with. Okay, don't forget about him. So then you take 6 cubed. 6 times 6 is 36. 36 times 6 is 216. So the final result here after dealing with your radical and your exponent is going to be 216. Okay, so parts C and D raise the stakes a little bit in this example, right? Because now we're evaluating an expression that not only has a fraction in the exponent, but a fraction as the base. Now, that doesn't actually change things very much, but it might scare you a little. So let's just take it slow and see if we can figure it out. So it's the same definition. If you want to evaluate some number 81 over 16 to the 3/4 power, this 4 is going to become a root, and this 3 is going to stay an exponent. So you're going to make this 81 over 16, but then because of the 4, you're going to have a 4th root of that fraction, and because of the 3, you're going to have a cube. Now to evaluate the 4th root of 81 over 16, you think of what 4 things multiply out to 81. What pair of 4 factors are there in 81? Well, 81 is 3 times 3 times 3 times 3. And 16 is 2 times 2 times 2 times 2. Okay, so the 4th root of 81 is 3, and the 4th root of 16 is 2. Don't forget your exponent. We haven't evaluated the exponent yet. We've only done the radical. So that guy comes down. So now we have to take 3/2 to the 3rd power. Well, 3/2 times 3/2 times 3/2. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. So ultimately, 81 over 16 to the 3/4 power becomes 27 over 8. So part D gives us 81 over 16 again, but this time it's raised to the negative 3/4 power. Okay, so the first thing I'm going to take care of is that negative exponent. So you got to dig deep in your memory banks and try to remember what a negative exponent does. Well, negative exponents flip the base, right? They reciprocate the base. So instead of writing 81 over 16 to the negative 3/4, I would write 16 over 81 to the positive 3/4. Okay. Now that I have that negative exponent taken care of, I can go ahead and take care of my fraction exponent. So this 4 in the denominator is going to give me a 4th root. So the 4th root of 16 over 81. And then this 3 in the numerator is going to give me to the 3rd power. So then I evaluate the 4th root of 16 over 81 in a similar manner. 16 is 2 times 2 times 2 times 2. Okay, so the 4th root takes those 4 2's and gives you back a single 2. The fourth root takes the 4 factors of 3 inside 81, gives you back a single 3. But then don't forget there's a 3 on the outside as an exponent that we have to bring down. 2/3 has to be taken to the third power now, which means we do 2 times 2 times 2 to give us 8, and we do 3 times 3 times 3 to give us 27. This answer shouldn't really surprise you, right? Because it's the reciprocal of the result we got in part C. Because the only difference between the problem in part C and part D is that part C had a positive 3/4 exponent and part D had a negative 3/4 exponent. And because negative exponents reciprocate, these guys are reciprocals of one another, right? They've been flipped. Okay, so in general, when you have a negative exponent, I would just start off by flipping the base and then go from there and evaluate your fraction exponent just like usual.